And we're back in 18-5 where we're in the middle of reaction number 3 trying to determine the rate law for this particular reaction right here. In the last podcast we have already determined that it is a first order reaction with respect to the bromate. It's a first order with respect of the bromide, but it's a second order with respect to the hydrogen, and we got that from the data table. So now when we write this reaction out, we can say that the rate, I'm going to write it down here. We've already determined the reaction orders up above. So I'm just going to write this down here. The rate is going to equal some rate constant K times the bromate times the bromide times the hydrogen squared, because it's a second order with respect to the hydrogen. And now to determine the rate constant K, you simply need to pick an experiment, plug in all the data, and then solve for K. I'm going to actually use the first reaction, and the reason for that is that we have 0.1, 0.1, 0.1 for our concentrations. It makes it really easy to do mathematically. So scrolling down, the rate in that equation was 8.0 times 10 to the negative third. That's going to equal K times 0.1 times 0.1 times 0.1 squared. And now if we divide both sides by all of those 0.1s, we have 0.1, 0.1, and 0.1 squared. We'll do the same thing to the other side. And 0.1 squared. Of course, all of these 0.1s are going to divide out, including the 0.1 squared. And so now K will equal the 8.0 times 10 to the negative third divided by all of these 0.1s, including the squared. And that actually is going to turn out to be 80. So therefore, if you were to write this rate law, you would say that the rate is going to equal 80 times the bromate times the bromide times the hydrogen squared. And there you go. Now if you want to pause this podcast and work through reaction number 4, go ahead. Otherwise we're going to keep on moving. So here's the last reaction we want to take a look at. Fluorine plus ClO2 forming FClO2. We write the general form of the rate law. So rate will equal some rate constant K times the fluorine raised to some unknown power times the ClO2 raised to some unknown power. Now we want to determine the reaction orders. Let's go ahead and do the fluorine, say in blue. The two experiments, if we have 1, 2, and 3, the two experiments where you keep the ClO2 the same, but you double the fluorine is 1 and 3. And so here, you multiply the fluorine by 2. If you compare 1 and 3 in terms of the rate, it goes from 1 up to 2, so that also doubles from here to here. So therefore, it is a first order with respect to the fluorine. Now in the case of the ClO2, you have to take a little bit closer look at this one. If you are comparing, we'll do this one in red, if you're comparing reaction 1 and 2, notice that the fluorine stays the same. But in this case, the ClO2 is actually quadrupling. Now this is a little bit of a curveball, and I wouldn't do this to you on a test, but if you're comparing experiment 1 and 2 as far as the rate, it also quadruples. So basically what happens is that they're doing the same thing. So this is multiplying by 4, this is multiplying by 4, which is a first order reaction. I will stick to simply doubling things, doubling concentrations, and that's about it. Alright, now let's go ahead and write out this rate law. In light of the new information, we have rate equals K times the concentration of the fluorine times the concentration of the ClO2, and that is shows the reaction orders. And now to determine the rate constant, again, rate equals K times F2 times ClO2. And we're going to plug in one of the trials. I'm going to plug in trial number 1, which seems to be the reasonable trial to plug in. The rate is 1.0 times 10 to the negative third. That's going to equal K times 0.10, and this will be times 0.010. And now when I divide both sides by those two quantities, of course these terms divide out, K then is going to simply equal 1. And so now if we write the rate law, the rate is simply going to be times the fluorine times the ClO2. All right? Okay, and this last section here, we're going to talk about mechanisms. I don't want to run out of time here, so we'll go ahead and stop this podcast. So in the last podcast, we're going to discuss reaction mechanisms and a couple of diagrams. We'll see you next time.